forget. Let me open up Canvas. So, yeah, we had a few exercises. Hold on. Pages. Alright, so we're on week 4, right?
Yep.
Alright, so more variables and printing. Strings and text, more printing. So, once I got to printing, and then I looked over printing, and I was just like, it just seemed like it was the same thing again. But
Okay, I'm opening it up. So you're thinking that there's not enough stuff?
yeah, yeah.
All right, so let me look at. How come I can never see it? Yeah, I only see just the first couple. I don't see it on my thing. For this coming week, when you start doing it, if it doesn't seem like there's enough stuff, let me know via Slack as soon as possible, and I'll get him to release a bunch more. And I'll tell him this week to.
Yeah, it just felt a little bit, like a lot of the same thing, almost.
Yeah.
Just a lot of printing.
I gotcha.
Which makes sense, you gotta get used to typing in print and then...
Well, yeah, but, there's not a great reason why we shouldn't already be doing loops and things like that.
Yeah.
Alright, so I'm gonna release a bunch of... I'm gonna try to give you too much for next week and see what you can get done.
Alright.
So, let's see what happens with that.
Alright.
Okay, so did you have any questions on it, or have you gotten pretty good at printing stuff?
Pretty good at printing stuff.
Okay. All right, so with that in mind, let me keep trucking, and we're going to see if we can maybe get into... so at this point, you're still working with variables, which is good. That lets us catch up a little bit on my side, but I want to get you into conditionals and loops here pretty quick. So let's see what we can do about that. All right, so let me do this. All right, so you can see the screen?
Yep.
All right. So if you remember from last time, we talked about this idea of a design pattern, kind of a proposed good solution to a common problem.
Yep.
And we introduced one specific design pattern that's kind of famous, something called MVC, and that's something you're going to run into no matter what programming language you're working with or what technology you're working with. There's going to be if you're writing Android apps, you're going to have a way to have your interface in one place, your code in another place, and your data in another place. So this model repeats itself throughout. So MVC says it's a good idea to separate your interface from your logic from your data. All right, so, and we introduced this in the context that we were talking about, if you remember our picture of all of our languages here. We were over here talking about kind of the history of of these languages. And let's see, we have not done the history of these guys yet because I want to hit Python first, right? We have not talked about Java and C#?
No.
Okay, that's fine. Okay, so...
actually, maybe we have.
Let me scroll up here.
Have we? I know we've talked about it. I don't know if we've.
Well, after we finish this, I'll give you the quick version of that one so we can get into some coding specific stuff.
Yep.
Okay, so we were talking about this in the context of kind of these languages and how they've evolved. So,
Yep.
PHP was kind of our first language made for the web. So before that, people were using this older scripting language called Perl for kind of doing webby things, but PHP had a lot of web stuff built into it. But as sites got more and more complex, the issue with PHP was your document had your PHP code in it as well as your HTML code in it. And last week we talked about how kind of web servers work and how they have to process non-HTML files. They have to process like PHP files. I'll bring that picture up here. So our web browser makes a request using the HTTP protocol to the web server. The web server retrieves a file. If that's an HTML file, it's done. It just spits out the HTML and JavaScript from that. But if it's one of these other kind of files, like a PHP file or a Python file, it has to run that program. And then the output of that program is going to be HTML and JavaScript. All right.
Yeah.
So as our websites got more and more complex, and people were heavily using PHP as kind of that first web language, the PHP pages, the .php pages, started getting very complex because they had a big mixture of HTML and PHP code all embedded inside of it, and it was kind of a mess. So that's where the idea of MVC came along, where they said, hey, we need to kind of separate this mess. So that is where a language like Ruby comes along. And really, Ruby's the programming language. Rails is a built-in web server. So when we talk about PHP, we have a couple of problems with it. One problem is that it doesn't have MVC built in.
Yeah.
And the other problem is you really needed to have kind of an IT skill set because you have to set up your own web server that supports PHP. So you needed to kind of install this guy and make sure he had the correct subsystem for executing these kind of files.
Yeah.
So it required some extra work that maybe not all programmers necessarily have. Okay, so now the long-term punchline we could say with PHP, though, is that it actually has historically survived and is still a fairly popular language because you've had this entire industry built up around it, where you have web hosting solutions that are out there where you can just either host it directly on the web or you can download something to run in your computer that already knows how to run PHP. So all you have to do is be able to double-click something and click setup. So now you don't need to have that IT skill set. Similarly, there's a whole bunch of third-party things that give it the ability to do MVC. So a lot of these things have been built up around PHP to kind of keep it current, even though PHP couldn't do it on its own. Now, in the meantime, Ruby on Rails came out, and this guy had MVC built into it as well as its own web server. That's what the Rails part of this is. So you didn't have to have the IT skill set. You didn't have to have, and then it also solved the MVC problem. The weakness of Ruby on Rails, which actually can also be considered maybe somewhat of a strength, is you were locked into doing things the Ruby on Rails way. Things happen, I mentioned here, things happen almost magically. Even today, Ruby's a pretty powerful thing. I mentioned last week, I think, that, for instance, Twitter is built using Ruby on Rails.
Yeah.
So we can say you can accomplish very powerful things very quickly. And then we'd say a downside to this by today's standards is you are locked into web. Now, for a long time, that was okay. People were making websites and that's all it was. But today, people are more interested, or at least also interested, in mobile applications, iPhone, Android, stuff like that, as well as desktop applications, where Ruby only really applies to making websites. So e-commerce type websites.
Yeah.
But, that's almost made a little bit of a comeback now since, for the better part of the last 8 or 9 years, let's say, native mobile apps on our smartphones have been very popular. But now you're finding a lot of websites having mobile, like fairly powerful versions of the mobile side of their web page. So that allows you to bring things back into the mobile world. Now you could still focus on Ruby on Rails as a skill set and still hit the mobile platforms with that without losing too much functionality, since we could maybe say a fairly high percentage of apps are utilitarian or business type apps where they don't need to have these super fancy animated interfaces and things like that. They mostly are just functional.
Yeah.
Okay, so then last on this list is this thing called Node.js. Now, I think I asked you last time if you had heard of any of these guys. So we talked about JavaScript and Ajax, jQuery, Angular, React, and you maybe had heard of a couple of them at some point, right?
Yeah.
But all these are actually fairly popular buzzwords, let's say, in modern web programming. So I'm gonna throw a slide in here related to that. So let's call this the JS crew. So we have JavaScript. We have Ajax. We have jQuery. We have Angular. And we have React. Now, JavaScript is a C-like interpreted programming language that runs within the web browser. All right, that's what JavaScript is. Now, one thing that we see a lot of in web technologies today is all these little buzzwords that come out, and 9 out of 10 times these guys are just JavaScript libraries. So if we go back to kind of the early days of our web pages, let's say you were watching a football game or something like that, or you were following a football game and you wanted to have the updated score, you had to keep hitting refresh on the page. With Ajax, so Ajax allowed a specific part of a page to reload without reloading the whole page. Okay? That's what Ajax was. But Ajax is also, let's put in parentheses right here, that guy's not a new technology. Just some smart person wrote Ajax using JavaScript and said, hey, this works really well. The browser is reloading just this aspect of the page. So I'm going to name it Ajax because it sounds cool. It probably also has some sort of underlying meaning. But all it is a specialized library written in JavaScript. It's not really a new technology. jQuery is also a JavaScript library.
Are you not going to be here?
Did what Ajax did, but better. All right, so one of the problems with Ajax is in JavaScript we have this thing called the document. It's kind of an object that references the web page you're working with and has a whole bunch of stuff in it related to the current rendered web page. And that document is a little bit cryptic to manually manipulate. jQuery created a structure around that document that allowed you to more conveniently get to kind of the sector of your page that you wanted to reload.
Yeah.
Okay, but at the end of the day, it accomplished the same thing Ajax did, just better. All right.
Yeah.
Now, Angular and React. So Angular is JS library made by Google, where React is a JS library made by Facebook. So these guys are kind of direct competitors with each other. And what this did is it did everything jQuery did in terms of the page reaching out to the server for updated info, but added the ability for the server to push new data to the page. So rather than your web page, maybe every 5 seconds or something like that, saying, contacting the server saying, is there anything new? Is there anything new? Is there anything new? Is there anything new? The server would actually just hit the page whenever anything was new. So the server would register themselves, or the website rather, would register itself with the server as a listener and say, please notify me when something interesting occurs.
Yeah.
Okay? And we're going to say React, same as Angular, just made by different people. Okay? Now, just to connect a one more dot in there, since we were talking about design patterns, we have another design pattern called the observer design pattern.
Yep.
And this guy says it's a good idea to be productive and get notified when something you are interested in occurs, rather than continually checking on the event. So the idea would be if you're if you're in study hall or something at school and you're working on homework, it would be in your best interest to just be productive working on your homework rather than every 5 seconds looking at the clock and seeing if the bell's going to ring.
Yeah.
Eventually the bell notifies you class is over. That type of thing.
Yeah.
All right, that makes sense. So that's what what the observer design pattern says. Angular and React is an implementation of the observer design pattern for web technologies. Otherwise, what you have with Ajax and jQuery, if you were getting updated scores on let's see, you're Philadelphia, so you're probably an Eagles fan if you watch football.
Yep.
Yeah, we're in Packers country here, so we're pretty sad these days. But
Sorry, we're not doing great.
I feel your pain. Our coach is about to get canned, I think, because nobody wants to blame the quarterback.
Yep.
But the idea here is if we're watching the Packers game or you're watching the Eagles game using Ajax or jQuery, the JavaScript that's running in your web browser has to make the decision when it's going to go and check, or how often it's going to go and check to see if there's an updated score. We're using Angular or React. When the score gets updated on the server, it can then push out to all the web pages that have said, I'm interested in updates to the score, and it will then update the score immediately when it has it. That way your web page doesn't have to, your web browser isn't being bogged down constantly having to use network stuff. And this actually becomes even more important when you think about mobile devices. Because with your smartphones, especially with your data plan, unless you're on an unlimited data plan, and even then, after a certain point they throttle your speed, you might actually care about the amount of extra data your phone is using, right? And even though it's not a huge amount of data, if every 3 seconds you're on a web page and your phone is checking in with the server, sending an HTTP request to the server and saying, is there an updated score? No, thank you. 3 seconds later, it does it again. It does it again. It does it again. That's going to add up over time to measurable data that's going to go against your data plan.
Yep.
All right? As opposed to the server just letting you know whenever it has an update, so you only have to deal with the data when there's actually data to be received.
Yep.
All right, so something relatively small is actually relatively important. Okay, so now up to this point, I'm going to throw a different, actually I'm going to add it to my picture here first. All right, so we're going to say, so different kinds of developers. We have front-end developers. That's these people.
Yep.
And these are back-end developers. Now, sometimes instead of back end, this is called server side. And sometimes instead of front end, this is called client side. All right, so when somebody says, I'm a client side developer, or I'm a front end developer, what they're talking about is they are writing things that run inside the web browser. So that means they're writing HTML to make things look pretty. And then they're also writing some, let's say, light programming that deals with validating forms and stuff like that inside the web browser. Now, that stuff then gets more powerful when we start thinking about some of these newer technologies like Ajax and jQuery or even Angular and React, which now allow the front-end developer to do some fairly legitimate programming. You know, it would no longer be fair to call this light programming. They can accomplish quite a bit using those technologies on the front end. Now, make some sense?
Yep.
All right. Now, the back-end developer, or the server-side developer, these guys, their job is not to make things look pretty. Okay, their job is to do the logic. So when you put your username and password in at Amazon.com, and that username and password gets sent over the internet to the web server at Amazon, and then somebody's going to write a program in here that's going to take that username and password, validate it against Amazon's web server, or database server, make sure you've logged in correctly, and then start gathering all your recent orders and all sorts of stuff like that, and bring in your secure credit card information, all sorts of stuff like that. That back end programmer's in charge of. So they're going to do a lot more with kind of what we would call maybe traditional programming and data structures, as opposed to making pretty interfaces. Okay.
Yep.
Now they're both actually important roles for any kind of programming today, because we're very reliant when we think about our applications today, whether it's a web page or a mobile application or whatever, we typically think about it in terms of what it looks like. And then secondarily, we think about it in terms of what it does. Kind of makes some sense? So I think historically, server-side programmers, or, what I would say the historical computer science person would say real programmers, look down on the front-end developers as, kind of being baby programmers, something like that. But what I have found to be more often to be true is that it is significantly more common for a front-end developer to be a pretty good back-end developer than it is for a back-end developer to be a pretty good front-end developer. So it's common for somebody who makes things look pretty to also be able to write code. And it's not as common for somebody who can write code to make things look pretty.
Yeah.
All right, so I might call these guys more general purpose over here, because they're kind of a jack of all trades. They can handle the larger side of the whole product. Whereas these guys over here really require a graphical person to make their work palatable, regardless of how well it might work. So now, with all of that in mind, when we talk about front-end or client-side development, the languages we're working with here is HTML and JavaScript, right?
Yep.
When we're talking about server-side programming, this is where we're talking about PHP, or Python, or Ruby, or a whole bunch of other languages that might be on the server-side thing. Okay? So if you were somebody who wanted to play both sides, so you're one of those front-end developers who who could be a real programmer and jump over here and do back-end stuff, you had to learn one of these other languages. Now, what I've kind of taught you is that all programming languages are the same, right? The syntax is a little bit different, but they're all based on C, but the languages, learning one language once you know one is actually fairly easy. But the perception typically, until a programmer gets convinced of that, the perception typically is learning a programming language is hard. Okay, especially when you're sitting over here as one of these front-end developers who maybe has spent their entire career just writing HTML and JavaScript. So they don't necessarily know what this world over here looks like. All right, so it can be a little intimidating jumping over and learning a PHP or a Python or a Ruby as a language, because the stuff you do on the client side in the web page is a microcosm of what is possible with JavaScript. So JavaScript is a general purpose programming language. It can do anything that Python can do. But when somebody's using JavaScript in conjunction with HTML to make web pages, the things that they will use JavaScript for is going to be just a subset of what JavaScript is really capable of doing, because they're doing web pagey things. All right, so jumping over to one of these languages might be a little intimidating. So with that in mind, a technology called Node.js came out. So Node.js is a server-side technology that uses JavaScript as the development language. Okay, so now client-side developers who are already, or front-end client-side developers who are already used to JavaScript can now go and use and do server-side stuff using the same language they're already familiar with.
Yep.
All right, so that's one benefit right off the bat. Now, Node.js also brings into existence the observer design pattern for conveniently letting front ends know about events. And it also supports something called streams. Not that important, but just another feature. So for right now, we can kind of think of Node.js as being kind of the latest, greatest, coolest server-side technology for web. And it just so happens to have a development language that matches the language that people are using on the client side with the JavaScript, which just so happens to be the same language that all of these fancy schmancy technologies are based on.
Yep.
All right, so you can be a I guess what might be considered a full stack. Let's just throw that in a slide real quick. Something you might see at some point is the phrase full stack developer. Okay, so full stack developer is a jack of all trades who can do server side, client side, and database. All right, so kind of a one-man show type thing.
Yeah.
Okay, and then a lot of times within this we have the idea of various stacks. So when we say full stack, you might have there's one of the stacks that's PHP based. It's called the LAMP stack. So that's PHP for the back end, that's HTML and JavaScript on the front end, and that's usually some kind of SQL thing for the database. But there are various names of stacks that are out there for people who do this stuff. Okay, there's another. Ruby on Rails is in and of itself a stack. All right, but generically, full stack means you know how to do front end, back end, and database.
Yep.
In at least one technology, but I'm telling you, you can learn another technology pretty quickly. Okay, so that's let's see. That was we actually talked about the solution already for that. Okay. Now you told me you are an Apple person, an iPhone person, right?
Oh yeah, heart and soul.
Heart and soul. Okay. So let's spend a few minutes talking about iOS versus Android. So you're an iPhone person, so you're an iOS person. Why do you think iOS is better than Android?
Well, it's just so much more simple. Just more simple to use. It's not as many. It doesn't feel as cluttered.
Okay. So, do you know who had the first App Store?
No.
Do you know who came out first? Who came first, iOS or Android?
iOS, right?
Well, I'm asking you. You're asking me? Yeah, iOS came out first.
That's what. Okay.
Yeah, iOS came out first. And actually, I mean, it's a fairly interesting story how this kind of came about. So iOS is Apple, right?
Yep.
And Android is Google. All right.
Yep.
So when iOS first came out, so that would have been 12 years ago, because I think iOS 12 is out now. So they release a new one about every year. So let's call it 12 years ago, whatever.
Yeah.
So iOS came out first. There's certain things that iOS did not have. So no App Store, no multitasking, no Flash support. All right, so I'm going to leave it at that for a second. So Android comes out about a year and a half later. Also, no App Store. Has multitasking. Has Flash support. Okay, do you know what Flash is?
Yeah, like on the camera.
No. I'm talking about like Adobe Flash. So if you've been to a web page before, like
Yeah,
Yahoo
yeah.
Games, Yahoo Games is Flash based, where you have basically computer programs that are running inside of a web page.
Yeah.
Okay, so lots of sites use Flash, right?
Yep.
Okay, or at least used to use Flash. It's been replaced by something else now, mostly, but back then it was extremely popular. All right,
Yeah.
so really, so when the first competition arose, once both of these guys were out, okay, and Apple already had over a year head start to get bugs out and stuff like that. This was the state of things. Neither of them had app stores. iOS did not have multitasking. Now, when I say multitasking, what do you think I'm talking about?
Like being able to use two apps at once.
Yep, being able to run more than one thing at a time. Okay, so that means if you were listening to music on your iPhone, you could not check your email. You had to stop the music to go and check your email. Where I assume now you might be running something on your iPhone and you go and check your email and you haven't even lost, your music's still playing in the background or something, right?
Yeah.
So it's something you take for granted now, okay? But it did not exist in iOS actually for a while. And it did exist in Android. Also, iOS did not support Flash. So any website you went to, the whole idea with Safari, mobile Safari for iOS was that, hey, you can actually browse web pages as if you were on a computer. Because up to that point, there were smartphones that had web browsers built into them, but they were pretty much crap. You were only if you had to really look at a web page was it even worthwhile trying to look at a web page on other smartphones. Make sense? So
Yeah.
iPhone and iOS was really the first time where it actually made sense to look at web pages. And
Yeah.
since a lot of web pages had Flash, not having Flash support was kind of a problem. When Android came out, it did have Flash support. So now we're looking at year 2 right now between these guys. So year 1 for Android, year 2 for Apple. When you look at them, which looks better on paper?
Android.
Android looks better on paper. Wow. Now, who was more popular back then? Android or iPhone?
What?
Which platform do you think was more popular during year 2? iPhone or Android?
During year 2? I don't know.
Your guy's still the winner. iOS is still by far the most popular.
Okay.
All right, because we want to dig into this a little bit. So we're going to call this. So these are some of the issues, but then we're going to add some more stuff. We're going to call this good battery life.
Yep.
We're going to call this guy bad battery life. All right, so things aren't quite as good anymore, right? It's like, okay, well, yeah, so you have multitasking, you have Flash support, all this stuff, but you get 30 seconds of battery life. Where iOS had very good battery life, relatively speaking. Now, this actually had quite a bit to do with the multitasking as well as the Flash support thing. So when we talk about multitasking, what we're doing is we're talking about running more than one app at a time. So iOS was written from the ground up as a mobile operating system. Android was based on the Linux OS. Okay? Now, you've heard of Linux before? Linux, Unix?
Yeah.
Okay, so these are popular, really, really powerful server operating systems. So we would presume that the multitasking model that Linux has would be very good, right? Like, I mean, Linux, if you have Linux running on a computer, a server or something, it can run multiple things at once. It supports multitasking. And that's why Android supported multitasking. So the premise would be that Linux's multitasking must be really well-written multitasking. Right?
Yep.
Okay, and that's a true statement. The problem is Linux has great multitasking that assumes you are plugged into the wall.
Oh.
All right, so
Yeah.
it doesn't take into consideration the amount of power that's being drained by all those applications running in the background.
Yeah.
Because you're plugged into the wall. Who cares? Okay, well, Android just adopted that and just said, fine, you can run as many apps as you want. Okay? They're all still cooking in the background using your battery life, even if you opened it a week ago.
Yeah.
All right, make sense? All right. What do you think, having said that, so when the App Store finally went live for both of these, Apple came out with the App Store first, and about, I don't know, almost a year later, Android came out with theirs. What do you think the most popular app on Android's App Store was the first year? Or what kind of app was the most popular app? What did the app do?
Maybe an internet browser?
Nope. It was an app that closed other apps.
Oh.
Because it's if you've ever used Android, it's actually a little bit difficult to go in and kill an app. You know, you have to kind of go through the settings and stuff like that and find the running applications and then tell it to close and, you know, like force quit it. Kind of like if you're on a Mac, you can go up to the Apple in the upper left-hand corner and click force quit. Yep. So it's a little bit convoluted to do that. So there were apps on the App Store that allowed you to conveniently close the other apps you had open on your phone.
Yep.
To save your battery life.
Yep.
Okay, that was the most popular app on Android. was apps to turn off your multitasking. Make sense where I'm going here?
Yep.
Okay, so the idea is that yes, Android had multitasking, but it was not mobile friendly multitasking.
Yep.
All right. Now, keep in mind that I'm usually teaching in front of rooms of 20 or 30 college students, so you pretty much always have an audience that's about 50% iPhone, 50% Android, right? Okay, so you can get them to fight with each other. All right. Well, so I also trick them sometimes. So this is we talked about this Flash support, and Flash still exists today, but you do see it coming into existence less and less. So we talk about Flash. Put before this is Adobe Flash. Okay, so first of all, iOS never had Flash support. Instead, iOS supported. Do you know what Flash's competitor is that has now taken over?
No. Oh.
HTML5. Okay, so HTML5 supports multimedia stuff like Flash did, where HTML4 was just making pretty pictures and text. It didn't support like games and stuff like that.
Yeah.
Okay, so from day one, iOS was kind of like one of the big proponents of HTML5. In fact, Apple was probably the reason that HTML5 became the standard, the new standard. Apple's a pretty big fish. So given that they're such a big fish, the the fact that they kind of dug their heels in and did not support Flash was probably one of the reasons why HTML5 was largely adopted by everyone. Okay. Android initially supported Flash, but now I don't mention that to my students a lot of the times. What I ask them is, I say, who in here has been a long time Android user? You get 2 or 3, 4 people that raise their hands, and then I say, well, how many of you appreciate that you have Flash on your phone? And then you get 1 or 2 that kind of raise their hand. Okay.
Yep.
The reality is, mobile version of Flash sucked. It was terrible. It wasn't even usable. If like you had a gun to your head and you had to do something on a web page that had Flash on it, maybe, just maybe, you could accomplish it. I'd give you a 30% chance, something like that. Okay.
Wow.
Now, it sucked for 2 reasons. First of all, not user friendly, so not really usable, and terrible for battery life. Okay, and this goes beyond mobile. Okay, you can test this yourself later on if you don't already have Flash installed on your MacBook. So you're on a MacBook Pro, right?
Yeah.
Okay, so if you don't already have Flash installed in there, at some point you can install it. Go to some, make sure your battery's fully charged. Go to some web page that has Flash running on the page. Now, what kind of battery life do you typically get on your laptop? How new is your MacBook Pro?
It's actually kind of like late 2013.
Okay, so you probably get like a 7 to 8 hour battery life, something like that.
Yeah.
Okay. So go to unless you're doing something crazy, but under normal use, you get 7 8 hours, whatever, something like that. Might be a little less now because it's got some miles on the battery, but regardless, you get decent battery life. If you go to a web page, make sure your laptop's fully charged. Go to a web page that has Flash running on it. Your laptop will be dead in 30 minutes.
Wow.
Flash is horrifically power hungry. All right, so that's bad news bears for mobile phones, right?
Yeah.
that's not going to work. All right, so I asked that question. How many of you appreciate that you have Flash in your phone? You get a couple of people that raise their hand. Now, if you go back to the early days, and this would have been when you were pretty young, they used to have the the iPhone versus Android commercials, where Android would brag about multitasking and Android would brag about Flash support. Then all of a sudden, you stop seeing commercials about Android bragging about Flash support.
Yeah.
You just stop seeing commercials. They never actually said anything about Flash. They quietly took Flash out of Android. Never told anybody. They didn't make any sort of announcement that we're removing Flash. Just Flash was gone.
Yeah.
And so Android has not supported Flash in years. 6, 7 years it hasn't supported Flash, even though that was one of their big marketing points early on.
Yeah.
All right. Similarly, now does iOS support multitasking now?
Yeah.
Okay. Actually, only sort of.
Really?
So we're going to call this iOS multitasking. So we're going to call this mobile-friendly multitasking. So what Apple decided is that there are 8 things that an app might want to do in the background. Okay? So one of them might be, so we can say like playing music.
Yeah.
Or getting location updates, that kind of stuff. All right. So the programmer of a mobile app, when they were writing the app, when their app goes into the background, they can choose By default, the app does not run in the background. It just gets put into like like a pause mode type thing. But they
Yeah.
can choose to hook into the operating system itself and say, I want to do one of those 8 tasks or more than one of those 8 tasks in the background. So I kind of want you to keep me on sort of life support. You don't have to run all of me because I don't need a whole user interface to be, clickable and stuff like that while it's in the background. But hey, I'm the Pandora app and I'd like my music streaming to still work, something like that. So the
Yeah.
app could register part of its functionality with the operating system and continue to have things running in the background, thus allowing it to have, let's call it the minimum battery impact, minimum negative battery impact, while still allowing you to do more than one thing at once. Make sense?
Yep.
All right. So we're going to say this was really good for battery life.
Yep.
And Android could no longer brag. Okay,
Yeah.
Android still had the battery life problem. All right. Now, what Android did do over time is they got better at keeping apps that were not being used recently running, only sipping the battery, something like that. So they would kind of automatically pause apps that were not constantly being run. So they were trying to make decisions about what was, what was common and or what was commonly being used and what wasn't. So that allowed their battery life to improve a little bit over time. Now, then what happened is batteries got a whole lot better. So one thing you probably notice every year when Apple makes their big announcement about the new iPhone is the battery life is the same as it was last year. Right? They say something like, oh, the processor is 2 times faster and the screen is 4 times brighter and this, that, and the next thing, and it has the same battery life. So we're doing a tons more stuff. We're doing a lot more stuff, but we're doing it all with the same amount of battery, so same battery life. So batteries are getting denser, and they have longer life, so they can fit more power into the same space. And then Apple's also getting better at miniaturizing the other aspects of the device to shrink it down even more. So, for instance, your laptop, how big is your hard drive in your laptop? You probably have a 128 or a 256 gig?
I think a 256.
Okay, so you have a solid state hard drive in your laptop. Your laptop does not have any moving parts. If you were to open up your laptop, what do you think you'd see in there?
A drive, a solid state, a drive.
I think you would not see what you think you would see. You would see a gigantic battery and then a little tiny circuit board at the top. Because your hard drive is not a normal hard drive. It's going to be soldered right onto the board. Your processor is soldered onto the board. Your RAM, so let's see, 2013, I think that was after.
8 gigabytes.
Yeah, so it's 8 gigabytes, but you cannot expand it, right? You don't have a slot to expand it. So, the amount of RAM you bought day one is the amount of RAM you're going to have forever. Because your memory is also soldered right onto the board. Because if Apple puts in a way for you to go in and add RAM, they have to put in a mechanism for snapping user installable RAM in. That takes space. That's space that could be used for a battery. Make sense? So what Apple does is they miniaturize all their stuff, solder it all together, put it in the very back of the case, and then fill the whole rest of it with a battery. So if you open your thing up, you just see a gigantic battery in there. You'd have to fish around until you finally found the computer.
Once in school, we actually opened up a computer, and there was a really big battery.
Mm-hmm. So that's how it works. Same thing. If you were to open up your iPhone, most of what you see there is going to be battery.
Yeah.
You're going to have a screen with a battery behind it, and then the components will just be kind of laying there behind it.
Yeah.
All right, so things have just gotten, our battery technology has gotten a lot better. So now each year our machines get faster and faster and faster and faster, and our battery life stays about the same. Because it either has a better battery or they've made faster stuff that uses the same amount of energy as the slower stuff used a year ago. that kind of thing. All right, so when we get down to it today, you really have Apple and Android are pretty close competitors when it comes to battery life. They're pretty close, and the reason for that is that they are both now using a hybrid multitasking model. So Android has moved a little bit closer to what Apple's done by being a little bit, pickier about how things run in the background. But Apple's actually moved a little bit closer to what Android does. That is allowing some apps to fully run in the background. And it does that so that, one of the things Apple bragged about, I don't know, like maybe 3 years ago, was how quickly apps would launch when they were in the background.
Yeah.
Because they never actually shut the app down. So the app was still fully running in the background, but it was kind of running in I'm almost ready to jump, like partially powered down state. So iOS today is more like Android was in the early days with better battery. And Android today is more like iOS was more recently. So they've actually become pretty similar in terms of how they've handled multitasking. The battery technology they're using is identical. The screens they're using are identical. It just depends on when the last one came out for what the resolution is or something. But, very, very competitive type things. So today we're kind of dealing with, at the end of the day, for which is better, we're dealing with ecosystem. So up until this last year, I was, I guess it's been a little over a year now. I always used iPhone. But now I'm an Android user. My wife is still an iPhone user, and I still use a Mac for one of my laptops. I have another PC laptop too, but all things being equal, one of the things I like about Android is I can download apps that let me do some things that Apple would never allow to be on the App Store. VPN apps and things like that, because Apple's very stringent about their what they allow on their App Store and what they don't.
Yeah.
And that's just the difference between those two ecosystems. I don't know that one's better or worse than the other. I think I would probably say that I had to reboot my iPhone far less often than I have to reboot my Android device.
Yeah.
I think my Android device gets into some unstable positions more often than the Android one did, or than the iPhone did.
Yeah.
Okay, so let me do the quick version of this stuff over here in our last couple of minutes, so we can jump into Python stuff starting next time.
Yeah.
So come down here. So we're going to call this, so we're going to say C programming language. So C, let's see, I've already done some of those two kinds of programming language things, right?
Yep.
Loosely typed, strongly typed. Okay, so I have to throw a new one of those in. There are three kinds of programming languages. We have procedural, we have object-oriented, and we have functional. Now I'm going to pretend like functional doesn't exist right now.
Yeah.
Okay? So I'm going to jump onto this slide, and we're going to say that C is a procedural programming language. Now, to kind of say what procedural is, I like to use like an example about a telephone. So if you walk into a room and I have a giant pile of wires sitting on top of a desk, and I tell you this is a telephone, at first you don't believe me because it just looks like a big mess. But then you walk up and you mess around with it, you find the buttons, you pick up the receiver, you hear the dial tone as if that exists anymore. But you're finally convinced that in fact it is a telephone because you see the big pile of wires. Okay? So procedural shows all the details of an implementation. Object-oriented hides the private aspects of the implementation. and only exposes the public interfaces. So the object-oriented version of a telephone would be something that you would look at and say, oh, that's a telephone. Now, you know if you were to crack that open, those wires are all in there, right? Okay.
Yeah.
But most of the time, you don't need to mess with those wires at all. So all that stuff's nice and stuck in there, so you never have to see it again because it just works. And only the buttons and the receiver and the things that you actually need to publicly interface with are exposed. Object-oriented programming, which is a more modern way of programming, one of the jobs of our programming languages is to solve problems the way that human beings solve problems. Well, in our real life, when you buy a new iPhone, it's this nice, pretty package with everything that there's really complex stuff stuck inside there, but you don't have to deal with it, right?
Yeah.
Okay, that's what we think of as human beings as being the iPhone. And only the buttons and the things that we actually need to click on are exposed to us, and everything else is hidden.
Yeah.
Now, when languages first came out, procedural languages, we just wrote a whole bunch of code, all the details were right there, and we had to fish through the wires to get to the parts that we actually needed to use. Now, that wasn't in line with how human beings actually solve problems, so a procedural language didn't do as good of a job as an object-oriented language does at mimicking the way human beings solve problems, but it was a human being's first stab at defining what a way to talk to a computer is. All right, so procedural languages, new languages that come out are not procedural. Procedural is very much the original way that programming languages were written. And once we started writing more complex programs, we needed something that allowed us to organize our code a little bit better, stuff those wires inside the box.
Yep.
That makes some sense?
Yep.
All right, so let me just create a couple of slides that we can power through at the beginning next time. So we're going to do C, we're going to do C++, we're going to do Java, we're going to do C#, we're going to do Swift, and then we're going to talk about Python variables, conditionals, loops, procedures. So, and remember, this maps to memory, asking questions, and repetition. From our very first slide of how do human beings solve problems.
Yep.
Make sense?
Yep.
Okay, so I'll get the video uploaded, and I'll reach out to Vincent and make sure I'm going to have him release like what I think is too much. And then you tell me, maybe follow up with me here in about 2 or 3 days on Slack and let me know if you have enough, and then we'll add some more. But I want to really challenge you this week and see how far you can get into it. Sound good?
Yep.
Okay. So same time, same station next week?
Yep.
All right, I'll see you then.
See ya.
All right, bye-bye.